Hello and welcome to another deep dive. So this time around, what we're going to be taking a look at is navigation mesh and navigation agents, something that's built into Unity and gives us a way of allowing our characters to be able to move around the world. So the built-in system in Unity, it is for characters moving along surfaces generally. So this will work for characters that are walking along the ground, things like that. It's not really going to be sort of the system you would use if you've got a character that's able to freely move around in all three dimensions. So something that was, say, for example, swimming, or that was able to be flying, or that's moving, crawling along the walls. You would need different systems for that. So the setup there in Unity is really geared towards things that are walking along a surface, with that surface being the ground or on top of things. So let's take a look at how we can actually use it. So first thing we need to do is we need to actually build our navigation mesh. So I'm going to go into the scene view here. And so we've got a bunch of different options here with our navigation meshes in terms of when we are sort of baking them. So we have this idea of being able to control the radius and the height and things like that. And those are really important settings because those determine where a character is going to be able to go. So if I just build nav mesh in this environment, then we can see these blue areas that will appear here show me the navigation mesh. So the idea behind navigation mesh is it represents a surface, and that surface, any point on that surface is a valid one for the character to stand. If I change things like the radius here, then that will, so say I drop that down to 0.1. And if we pay attention here to how close this gets to these locations, if we clear it and rebake it, you can see it gets in a lot closer. So what that would mean is if my character radius didn't really match particularly well with this, then my characters might be staying too far from the walls or getting too close to the walls. So it's an important thing to consider when we're actually building our navigation meshes there. And it's why when you look in games, so many of the characters have quite similar sizes. And that's because that means you can just use that one navigation mesh safely with the multiple different characters. Similar thing with height. So height, if I chuck in a cube, so I've got a cube here, and that's obviously way the space under that a character would not normally be able to fit. So let's clear and rebake. It hasn't really done anything. It hasn't really done anything because for things to be part of the navigation mesh here, generally what we need to do is we need to mark it as at least being navigation static. What that means is that it is there as a fixed thing in the navigation mesh and we bake it in. Because navigation meshes, we have a baked version, but then we can also be modifying those at runtime. So we can have obstacles, things like that, cut sections out of it. So if I clear and rebake this again, well, now we can see this is creating an area where we can't go under because of that height. So the height matters. That's the maximum height there of our character. So again, if we got that wrong, we could have a character trying to walk under things that they can't fit, or a character thinking that they can't fit under something when they can. So getting these settings right and getting them right early on is really important. Having a consistency early on in your game for the size and scales there for characters is really important. If you just build the characters freeform without tracking and making sure things are a consistent sizing, you will run into problems. And the later you run into them, the bigger the engineering overhead potentially in fixing them. So you need to be really cautious with that. So, okay, the height limits and radius affect where it's going to be able to build. Slope is also a factor for this. So my cube here, if I make this cube much larger, So if we do that, and then if I regenerate the navigation mesh, we'll see we're getting navigation mesh going over onto that. That's because of our step height here. If I raise that up a bit higher, then now we have two disconnected navigation meshes because we're saying that the character can't validly step. So again, step height has to tie into the capabilities of our characters. We can also, as we're mentioning in terms of slope limits, so with this, if I set a fairly shallow slope and rebake, navigation mesh goes up that. But if I make that really steep and then bake it, still just managing to, if I get over that 45 degrees and then bake, then it no longer goes over it. So getting these limits right and matching them with our character's capabilities are really important. Really, really key to make sure we're doing that. Now, what if we had something where we wanted to obscure the nav mesh, but only at a sort of, a particular bit of time in the level? Well, we can again bring in a cube. So we've got our cube over here. Let's bring this up. And so what this is going to do is we want this to create an obstacle, but we only want that to happen, because at the moment it's not blocking the nav mesh because we haven't made it nav mesh static. This might be something that we turn on at runtime. What we can do is we can give it a nav mesh obstacle component, and we can set the shape. So we've got a very constrained set of shapes here. That's because for performance, we want to be able to cut out the nav mesh efficiently. And then carve is going to make it actually do that cutting out. So what I'm going to do is just for now, move my inspector over here so I can see my nav mesh setup. And then if I turn on carve, you can see it blocks it out. And as I move this around, the nav mesh updates and adjusts dynamically with that. So we can have dynamic obstacles there because this, if I turn this off and on, that'll control whether it's blocking that area. As this is moving, that can further block out an area, which will cause characters to repath, things like that. So really valuable way of us being able to just easily set up obstacles. And we've got a couple of other settings here. Now these are ones that we often don't need to mess with, but let's create a platform. Bring this up. What I'm going to do is I'm going to make this a bit larger. And we're going to place this here. And we will make this, again, navigation static. So let's initially just bake. So we can see we have this nav mesh appearing on top. And we can also see this idea for generating Offmesh links. So if we bake that, then we're not getting any initial ones in there. But if we turn on Offmesh link generation, then we will get, so Offmesh links are connections between separate sections of navmesh. So in this case, it's creating a link from here down to here. So that would allow us to have our characters go and jump off of this if we want, and we can control the height. So if I raise this up higher and rebake, it's still just managing to do it. But if I drop this, and maybe we set different ones so they can drop from one, actually, yeah, so like that. You can drop two, but they'll only be able to jump one. Then if I raise this up high enough, we won't get any links there. If I turn off jump and just bake ones and then lower this a bit, so we get our ones for being able to connect to it. So for dropping off of that, if I duplicate this and set up another one over here, we'll just bake. And then let's turn on being able to jump. So we can see we get our connections. And these ones, we'll notice there's a bit of an arrow that we can see. So the arrows indicate the directions. So these are off-mesh links are one-way things. So if we need to link between two things like we're doing with the jumps here, those links have to go both ways. Now, the generation of the links is one thing. Following these is something that we have to implement in our own setup. So that's something where our character controller, we have to implement that logic for it. You can use off-mesh links for more complicated things. So if you've seen Bioshock Infinite, where there are skylines, so these rails that characters can jump on and loop around the level, those are able to be done with a set of these off-mesh links. So ones that are chained together effectively is what it's able to use there. But so we can auto-generate these, but don't assume that the auto-generation means that, okay, yep, cool, it'll just work and your characters will do what they need to. You actually have to implement special logic in your project for handling transiting on those off-mesh links, and in particular for usually controlling animations, things like of that. And that's a non-trivial area to get that set up. It requires specific stuff in your character controller, and it's very specific to how your characters move, and then also in the navigation side of things. So that's a little bit out of scope for what we'll be looking at for this, but that is something where the actual, at least, generation of them, you can generate them, and then the logic for following them is something that can then come along after that. So, okay, we can bake our nav mesh, which is pretty cool. We can generate our links, everything like of that. But then how do we get characters actually moving along it? So I've got this player-controlled character here. I'm going to bring this back over here. And then I've already got a NavMesh agent set up on it. And we can configure our different agent settings here. So we've got our different agent types. So we can add in extra ones. So in this case, we've got one called humanoid with this particular configurations. We could easily set up ones for other characters as well. And we get this nice little visualization for it. We can also then, when we are working with stuff, we can set up different areas here. So being able to tag things as walkable or not walkable or jumps. That lets us do things like if we wanted characters to seek out particular areas or prioritize particular areas, we could be looking at doing that if we wanted to. So we've got our setup here with our agent. If we take a look at the things we've got, so the agent, we can control where the agent is actually positioned. And if I adjust the base height here, we can see this cylinder. So that cylinder is really important. That corresponds to the space that agent is taking up. We can control things like the steering behaviors for that agent. So its speed, acceleration, areas like of that. And we can also then control things like its acceleration, stopping distance, a lot of different controls over how it's actually going to be moving. We can also get rid of our character control. We don't need that. That was for an earlier project. We can control what areas it's allowed to be using. So, okay, well, we obviously don't want it using not walkable areas. We only want it to be using walkable ones, so we can control that. And obstacle avoidance. So the obstacle is really important to understand different terminologies here. So obstacle avoidance, it's very different whether we are avoiding another AI versus whether we are avoiding something like of the cube that we have cutting out the navigation mesh here. The obstacle avoidance that it's referring to here is specifically referring to avoiding other NavMesh agents. So it's not about avoiding things that are carving out the navigation mesh. So there's two ways we can avoid things. For things that are very slow moving or are static, we generally carve out the navigation mesh. And so we don't specifically avoid them, we path around them. But for rapidly moving things, for dynamic objects like other agents, we don't really want to carve the nav mesh around. Because you can imagine, if we carve the nav mesh out here, then it means that character is off the nav mesh. So we need to use a different system, which is this obstacle avoidance one. So that allows us to control, the settings there in terms of, well, what radius and height does it have with that obstacle avoidance. So really important that this is specifically referring to avoiding other characters. What I was mentioning with now the off-mesh links, we can set it to auto-traverse them. And we'll see what happens when we have auto-traverse on. We will do a little bit of a test with that. But generally, I would recommend having that off and manually controlling what happens. So in terms of how these work, what I've already got set up is a bit of infrastructure where these agents get told, well, here's your destination. So they get told to move to a particular location, and then we will go from there. So first thing I need to do is I need my NavMesh agent. And you'll see I've already got the Unity engine.ai namespace in there. So I need that for being able to perform the moving. So when I do a move to, what I want to do is I first want to pass that on to set destination. And I'm just going to pass directly in the location. I'm going to get rid of any stuff here for stopping distance first. So I just want to set destination. So what this can do, it can just go, hey agent, your destination, I just want you to set it. Just set it to this location. And let's just see what happens. Let's see what behavior we get with this. So we're up and running. And we'll be able to right click to issue an instruction. So we give it an instruction to move, and it's getting grumpy at us because we need to be retrieving the agent. So we'll do that. We don't need the character controller anymore, but we will chuck in a require component just to make sure that we have to run this using an Offmesh agent. This should then allow us to issue an instruction, and the character will then path and move to that location. As you can see, they head over there, and while it's running, if I go to scene view and select navigation, we can see it's showing the path there. So if I click over here, go back to scene view, you can see path that it's taking. And you can see the location that it's heading towards. So really powerful for being able to control for moving towards things. Let's see what happens if we try and move towards that cube. What happens if we tell it to move to a location that is an obstacle? In this case, nothing. So it doesn't try to move at all. Whereas what we'd really ideally want is it moves as close as possible to it. So what we can do is we can actually find the nearest location to this spot. So there's different ways that we can be doing this. So agents have an option for us being able to do a sample path position. So what this can do is, so we give it an area mask. So NavMesh leave, so the NavMesh all areas. So we just want to grab nearest location in all areas. We could set up something so it's providing that sort of filter option. We want a range. So we want a distance that it will search for a nearest valid point. Nearest point, search range. So probably the nearest within 5 meters, I think far enough. Nearest point search range, and then hit result. So NavMesh, hit. So this is similar to what we can do with like of our raycasts. So if that returns true, then that means it found a location. And so we can then just move to that. So searching for the nearest valid location and then heading towards that. So let's run this. What we first want to do It's just testing. Okay, well, that's giving us back nothing. So this is not actually letting us set nearest point near that destination. And that's because there are actually different versions of this sample. So we actually want to use the navmesh.sample position because that lets us provide source position, hit result, the search range, and an area mask. So although there's sample path position, that actually finds the nearest location relative to the path you've currently got. So this goes away. So there's a lot of very similar named functions within the agent and within the nav mesh. Key thing to know which ones you're wanting to be using there is if it's an agent version, it's generally going to be based on information the agent's already gathered or determined and is going to be based upon that. Whereas the nav mesh one is if you're wanting to do sort of more arbitrary queries at any location in the world. So then we'll be able to run this. And then when we do that, so now we can move to here, which is good. We still get when we click on here, it's still managing to, if we get close, it does manage to issue the command. But we do find that it is, from what we can test, is what happens if we, we'll debug this in a moment and we'll be able to see. Because if we click on this, what's also happening there is our interaction system is actually going to be picking up on that. So we could make this that our interaction system is going to ignore that particular one. So obstacle there, if we move that over to ignore raycast, and our interaction manager only gets the ones in default. And now, and so it'll move to the nearest location to that. So you can see, it's moved there, which is good. So we can get it to move towards the nearest valid spot. So find nearest spot on navmesh and move there. Well, what if we've reached it? How do we determine if we have actually reached that location? So there's a few things we need to actually be checking there. So this, our agent, we've got this remaining distance. So that's how far from its, where it currently is to its endpoint. So we could check, well, has it reached the end? The catch with that is we might want to intentionally be stopping a little bit away from things. So the agents actually have this idea of a stopping distance. So we would check, well, okay, if it's less than this stopping distance, then hey, we're at the destination. Let's see how that works. Let's see if that gives us the result that we're after. Should mean that we know immediately as soon as we've reached it. But what we'll find is it, without us even giving it an instruction, it's still outputting that. Now, it will correctly, then when we get to the location, work. But so we need it to not do this when it doesn't have a path. So for knowing it's at the destination, we also want to check that it has a path. So have a path and near the endpoint. Also means that what we want to do is if we, for some reason, are cancelling a path, things like if that, we want to get rid of the path here, and you can actually see we've got this option for resetting the path, which clears it. That way, we just know that we have actually found our path, we've gotten to location. We could do a similar thing here because we did notice that it was spamming out. So what we could do is after it's done it once. So what we'll notice with heading to locations is doing that check for if it's got the path for the remaining distance, that doesn't end up firing. If we do set a little bit of a stopping distance, it will. And the reason being is that that has path variable is getting cleared really rapidly. So what happens if we have that stopping distance at 0 is this gets cleared before that remaining distance has reached 0. So we need to be tracking a little bit more information outside to know, have we gone from having a path to now we've actually completed it. So what we can do as a starting point is keep track of, have we set a destination? That's the key thing here. So we know here destination set is true. We know if we're cancelling, then destination is set as false. So, okay, we now know whether we have set a destination or not. What we can check here is, okay, well, if a destination is set, then is the remaining distance this? And I'm going to remove the reset path for now. So if we had a destination set and we've reached that point, then our destination set here becomes false. So that should be clearing that. So we can test and see how that behaves. Because the key thing is we need to know reliably, have we reached the destination? And regardless of what we have as our stopping distance, because while there are cases where we could use a large stopping distance, like if we're moving through patrol points, things like that, there are cases where we want really precise positioning. So we can see this hits that point of saying we're at the destination really early on, and it doesn't hit it at the end. And we can take a look and see sort of what's happening with that. But what that'll be is there's a brief window there where we are finding the path and that remaining distance is actually going to be invalid. So the remaining distance hasn't actually been properly updated yet. So what we could be checking is a couple of different things here of, okay, we know that we've got that path coming through, and we can check and see what the status is of our Navmesh agent as we do this. So once we have this set up, we then issue the move command, and we'll be able to see, so remaining distance is currently 0. We do have a destination set, and if we take a look at our Navmesh agent, we take a look at the status of things, we can see that, okay, it doesn't currently have a path. And we can also see that the path is pending. So that means it's currently trying to find a path. So we could add in a check where what we're doing is in here, if the agent is, so path pending. So if the path is not pending, so we have a destination set and the path is not pending, then that remaining distance should be valid. So we know that it's at least completed a path find, because there is a bit of a delay there between requesting a destination and getting that path back. So let's try that. So we issue the move command. So we've reached there, we get the at destination. So we're reliably getting our message. So, okay, we now know reliably when we're at our destination, which is good. We can control how the character moves along that. So, for example, if I wanted them to move faster, then I can do that. So up their speed. you can see they'll zip around a lot faster. We can change that angular speed is how quickly they'll rotate. So if I make that like 30, then we'll see really slow, but that rotation is a rotation of the object. It's not going to influence the path that they actually take. So that's an important thing here, that angular speed has no bearing on the path that they take. Doesn't matter what I set that to, it just controls how quickly they rotate. So that's something to keep in mind there. If you're needing it, that rotation speed, things like that are impacting the path, that is something where you would need to do custom handling for that and potentially a custom pathfinding solution for that. So it looks pretty decent. It's able to be moving around quite happily. Well, let's see what happens with this auto-traversive links for that idea of jumps, because we know that it actually did have support for generating those links. So we're going to create some platforms here. And let's make these appropriately sized, and we're going to make these navigation static with off-mesh link generation. So these two platforms here, let's build our nav mesh. So we can see it's added in those jumps, which is good. And let's raise these platforms even higher so we get nav mesh under them. And we'll make the drop height 5. Should be just enough. Cool. So platform 1, platform 2. And then let's take our character here and let's move them onto this platform, because they are set to auto follow nav mesh links. So we'll run this and let's see what actually happens. So we've got the inspector up. You can see that it is set to auto traverse nav mesh links, which is good. So let's issue a command down onto the ground here. So it heads, but it won't actually follow that link. So just because it's being set to auto traverse it, we still actually need to provide support for it being able to follow along it. And same with this, it's not even going to try and move to the ones on the other platforms there. So even if I just double check that they're baked, and I would need to, with this, turn in the jump ones. So let's see what happens then. So that was why it wasn't following those. They were in a different area. So it's not going to properly follow the jump ones, but it did follow our drop one because we turned on the jump support. So it's not a great following of it, but it does successfully follow it. Now, in terms of with the jump one that's happening between here, so that's something where it has generated the links. We can see that they are bidirectional, but if we then, and I'll put the game view here so that we can see the debug display of what's potentially happening. So when it's running, you can see it's not even finding the actual path there for it. And if I select the character, we get a little bit more info, and we're getting nothing. So we can check here and see, okay, does it actually successfully even sample the position? So it's managing to follow the other ones. So we may be able to get it to follow the jumps. And so this, we're not actually even picking up when we are clicking on that. So that is actually, oops, down here is where I need to click. So we're not even getting anything coming through for that. And the reason there is actually that's down to our interaction manager. That's because if we look at our ground is tagged as ground. So these also need to be tagged as ground. If we do that, we likely will be able to move them between these. So we're running. Now, as I said, it's not great following of it. You can see it's just a super rapid thing there. And if we go down here, click, so it's not actually really sort of jumping. So it traverses the link. So when we turn on that auto link traversal, it does move between them, but it is just essentially doing an interpolation between the points. It's not going to be following anything particularly sophisticated with that behavior. If you're wanting to have it follow sophisticated behaviors there, you actually need to turn off that auto traversal. What we'll see happen here is with auto traversal off, finds the path, but then it stops, and it stops at the entry to that actual off-mesh link there. And what we'll be able to see is we actually have these particular things of, okay, well, are we on an off-mesh link? So you can check F. Are we on an off-mesh link? Now, this is something where, again, state-wise for what I normally would do with this is I would actually have tracking outside of this off-mesh link status, because we have not started, in progress, finished. So entry, essentially being able to transition into it, being able to transition out of it sort of process there. So I would need to be keeping track of my off-mesh link status here. Which that's going to, by default, be not started. And I want to make sure, crucially, anytime we finish, get to a destination, cancel command, things like that, I want to make sure we're resetting that. So here, okay, well, we're on the off-mesh link. Well, here's our off-mesh link status. Not started. If that's the case, then we're in progress. Otherwise, is the off-mesh link status our in progress one, which I might probably chain those together like that. So those are the only two ones we need to actually keep track of. And then I could have off-mesh link progress, which again, that's something I would reset here. Now I'm going to do just a really naive setup here of being able to just interpolate between the 2 points. Have we started moving along the link? Because we can actually get more information about the off-mesh link, because we can see we've got this next off-mesh link data. And if we take a look at that, we can see we've got this start position and end position. So that means, well, if we have our, actually, and this was where we could have our off-mesh link speed. No, actually, I can just use the agent speed, which means I don't even need to track progress. Because what I can do is here, I want to have a vector 3 move towards, get my agent's position, which I can just use my transform position for that. So transform position. So get the current position. My target is going to be my agent's off-mesh link end position. The maximum delta is going to be my agent speed my time.delta time. So this is my new position. New position. And then I could check if I'm near to that particular one. So I don't think we've got a near to, no, we have approximately. So what I could do is compare these two values if they're roughly the same. So I could get the distance from the new position to the off-mesh endpoint. So the next off-mesh link data, endpos. So if that's approximately 0, well, that means we're done with this off-mesh link. So that means we can change our off-mesh link status back to not started, which I don't need finished then anymore. Would depend on how complex my movement was. I might need more of a detail there. Are we moving along the link? Reach the end. And we can tell the agent to complete that off-mesh link. So let's see what we get with this behavior. We're activating the link, we're warping location. Will this make the character move the way we expect? Let's find out. So we've got our location here, try to move. So it just immediately is saying that they're at the destination. So we notice it's not moving, and when it gets to the off-mesh link, it's very rapidly going and then saying it's at the destination. So one of the things when we transition onto a nav mesh, or sorry, onto an off-mesh link, is we actually need to tell the agent that it can't actually update the position anymore. Because what this will do is this turns off the auto-updating of things. So all of this we turn off. And then when we're done is then when we would turn these back on. This way, we're able to fully manually control where the agent is located during that off-mesh link. So then with this, if we run this up and then test it, issue our command here. So it's stopping. We've noticed it's not moving when we issue the command there. It gets part of the way and then stops, and it's saying it's reached the destination. So there's a couple of things happening with this. One of the key things is, well, if we're already on an off-mesh link, don't want to actually mess with stuff here. So if not on an off-mesh link, and then we've got these other ones set, which means we don't need to be clearing that status. That just means that while it's on an off-mesh link, we're not going to prematurely complete the behavior there. And then finally, warp is not really going to be reliable in this case, in that we're trying to move off of the nav mesh. So this is where we can just directly set the transform position. So if we do this, then what we can do is we'll be able to run this up, issue our move command, teleports over, gets the destination, move back down, so it's headed over to the ground. If we start that back up again, and then we can click on the ground and we'll see it will follow one of the jumps down. Gets there. Now that's something where we would be able to differentiate between whether this is a jump down or whether it's something where it's moving up, and we could control that behavior along there. So for example, what we could be doing with this is if I set up a coroutine, my enumerator, follow off-mesh link, then a couple of key things that I'm going to be doing with this, bring these into here. And then I can also bring this stuff in here as well. So that then what I can do is, if we've just started on the Offmesh link, then I start the coroutine, follow Offmesh link. This I will move into the logic down here. Just makes it a little bit cleaner. Because then what I could be doing in this is, well, this is not the case. While we're not proximally at the endpoint, then we do this, yields, return new, wait for end of frame. For our new position, we can store this up here. Which that new position is just going to can start out as our transform position, just in case we happen to have some odd data and it was already immediately there. So flag the link as completed. And here we return control to the character, agent. Start Offmesh link. Disable Offmesh agent. And then here we're moving along the path. And with this, we could customize how that actual movement is happening. So this, we could be playing an animation, and we've got a nice control now over that just happening in the background. It's separated from the rest of our logic, which is good. We can simplify this sort of setup here a bit if we needed, but it gives us a pretty clean setup for being able to move along these links. And you can use those Offmesh links for a lot of different things. So you could use them for being able to climb up ladders, stuff like that. And we just need to check the particular type of thing, and then that'll allow us to work with it. So key thing when we're working with navigation meshes and navigation mesh agents. So firstly, the sizes for things. The radius and the height matter. We want to make sure that those are set appropriately for our characters, and that we make sure our characters are quite consistent in those heights and radii that they use. We also can customize things like our slope and step height, things like being able to drop down or jump between surfaces, we can customize as well, and it can build these links for it. Now, with having those links set up, then our agent itself, often with that, we want to have it under our control. So we want to turn off that automated traversal of links. That's going to allow us to control carefully what's happening, to detect it transiting onto the link, to manage that transition, and then to transit it back to Unity's control. But it's important that we need to keep in mind that with doing that, we have to very carefully position the character when we're at the end. We want them to be right at the actual endpoint of that Offmesh link. That's why we are, in this case, moving them directly towards it. If we're doing an animation, we need to just make sure it finishes properly at that exact right point. Checking if something has reached its destination is not as simple as just checking the destination. Do need to check other things in terms of if we've got path pending, if we're on an Offmesh link, we have to make sure those other things are checked, otherwise we can get false indications that we're at the destination. So really important to make sure we're doing those checks quite carefully. If we have multiple agents, then we will get obstacle avoidance that will happen there. It's not amazing obstacle avoidance, and you may end up needing your own solution for it, but you will get a basic level of obstacle avoidance there. We've seen we have characters in the world can avoid static obstacles, that we can turn those obstacles off and on. So like of our cube here, is something that we can just turn that nav mesh obstacle off and on. Which is really, really valuable, really handy for if we've got dynamic things changing in the world. If you want to have things block off sections of the nav mesh, we can do that using those obstacles. So dive in and experiment with the nav mesh stuff, see the kinds of things you can create there. Experiment with having different types of movement here for along those off-mesh links. We've now got this, so it's really tightly constrained into, we've got a single point where we need to make changes for how that moves. So look at setting up a jump. Look at setting up, different behaviors for it falling, things like that. Those are things that you can do, and it's just now a small self-contained area, and you're just having to adjust the position there. So experiment, see the kinds of things you can create with it. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects there freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.